Hello and welcome to the course of manufacturing method. Myself Somobroto Chakraborty, and today this is our third lecture. Today in the last lecture I have discussed about the fundamentals of casting process. In this lecture we will discuss about the casting process and equipment. So casting process and equipment, this is the first lecture of this topic, and there will be another lecture in this topic only. So first we will see the lecture objective: to present the principle of different casting process, to classify the casting process efficiently, and to understand the characteristics of each process along with typical application advantages and limitation. So casting, first we will come to the classification of casting. The major classification, major categories follows: expandable mold casting, and in case of expandable mold casting is further classified as expandable mold permanent pattern casting. That means in case of expandable mold casting, the mold is not permanent. After each casting the mold is broken, so that's why it's named as expandable mold casting. So in case of expandable mold is further classified as expandable mold permanent pattern casting, expandable pattern casting. Now there here comes the permanent mold. So we will see, this is a broad classification of metal casting process. So in metal casting process there is three type of casting. First is expandable mold casting, second one is permanent mold casting, and third it's a mix and match of these two type of casting, that is composite mold casting. Another classification is here, that is single crystal growing. This single crystal growing thing is not in our syllabus, so we will see only brief detail of it after at the end of the this casting process and equipment topic. So it is not so important, but the important parts are expandable mold casting, permanent mold casting. In case of expandable mold casting, there is sand casting, shell casting, plaster molding, ceramic molding, and expandable mold casting. These are the type of the expandable mold casting. Now in case of expandable mold casting, expandable mold with permanent pattern casting, in this category sand casting, shell casting, pla- plaster molding, and ceramic casting. These are the type, these are the first type. These are the example of expandable mold permanent pattern casting. And evaporative pattern casting and investment casting, these are the type of expandable mold, expandable pattern casting. So in this lecture, in today's lecture, we will see sand casting, shell casting, plaster molding, and ceramic molding in detail. And after this lecture, in the next lecture, in the next casting process and equipment 2, we will study about evaporative pattern, investment casting, and slush casting, pressure die casting, centrifugal casting, squeeze casting, and semi-solid casting. We will study about this in the next lecture. So in this lecture we will study about sand casting, shell molding, plaster molding, and ceramic molding. So let's start with expandable mold permanent pattern casting processes. So what are the expandable mold the major categories of expandable mold permanent pattern casting processes are sand, shell molding, plaster molding, ceramic molding, and vacuum casting. This casting is also not so important, but we will discuss it later. So right now here is the advantages and limitation of some of the casting process, such as sand casting, shell molding, plaster molding, and ceramic molding. So one by one we will see the advantages advantages of sand casting is almost any metal can be cast. There is no limit to part size and shape or weight of shape or, there is no limit to shape or weight, and tooling cost is very low. So this is the advantage of sand casting. But the finishing, but surface finishing, some finishing, but after the casting there is some finishing or finish machining is required. Bec- and the surface finish is not so good, and it has wide tolerance. That means the dimensional accuracy is not matched with the design in case of sand casting. That means further machining is needed in case of sand casting. Next is shell molding. Shell molding can give good dimensional accuracy and surface finish, and shell molding has a higher production rate. But the limitations of shell molding is part size is very limited and expensive pattern and equipment. The cost is high and the part size is very limited. Next, in case of plaster molding, intricate shape, plaster molding and ceramic molding, these two can be treated. These two can be named as precision casting. Why precision casting? Because here surface finish and dimensional tolerance is maintained at higher accuracy at or it is maintained for plaster molding and ceramic molding. The dimensional accuracy is maintained more accurately, so that's why they are called precision casting. So see, the advantage of plaster molding, that is it can make intricate shape. Intricate means highly complex shape with good dimensional accuracy and surface finish. The plaster molds has low porosity. So we will see about the porosity, what is porosity, in the later section of this lecture. But the thing is that due to porosity, the surface finish becomes due to porosity, surface become porous. So if we have low porosity, if we can have low porosity, that can result to good surface finish. And the disadvantage is plaster molding is limited to non-ferrous metals only. Means ferrous metal cannot be casted using plaster mold. Only non-ferrous metals can be casted, and part size is limited, and the volume of the production is also limited. In case of ceramic molding, intricate parts or complex shape can be made. Close tolerance is there, and surface finish is very good. And the only limitation is mold making time is very long, and there is limited part size. The part size is very limited. So these are the advantages and disadvantages of different casting processes in in the category of expandable mold, permanent pattern casting process. Now we will come in detailed study of the sand casting. So sand casting is one of the oldest method, and but it is still prevailing method. Means it is still used as a form of casting. So the typical application of sand casting includes the typical application. These applications are important. The typical applications is machine bases can be made, large turbine impellers, propellers, plumbing fixtures, and wide variety of other products and components can be made using sand casting. Now sand casting is consist of, means the process is consist of first placing a pattern. That means a pattern is made. We will see in detail what is pattern. So first, pattern is the shape in which the pattern is the desired shape. Pattern is our desired shape. So placing a pattern that having the shape of our desired casting in sand to make an imprint. This is our first step. Secondly, to incorporating a gating system. Now, what is gating system, and in detail of the gating system we will study in the study later in this lecture only. And next, the removing the pattern. After after incorporating the gating system, the pattern is removed and mold cavity is filled with the molten metal, then it is left for solidification. Means it is allowed to cool until it solidifies. And after it solidifies, after the solidification is done, after the certain time, the mold is broken. The mold is broken, that means breaking away the sand mold and removing the casting. This removing of the casting is the last step of sand casting. So these are the steps of the sand casting. Now we will move to the sand casting as a, see here, by patterns. These patterns are made by pattern making, core making, and making the getting system. So this, all these are in pattern making. After there is sand is, after this here sand is prepared, and using this pattern and sand, complete mold is prepared or mold cavity is prepared. After the mold cavity is prepared, from the furnace the metal is melted, and in the mold cavity molten metal is poured. After the molten metal is poured, there is solidification and cooling. After solidification and cooling, shake out and the removal of risers and gate, then post processing. Then after this, here the casting process, here the casting process ends, here the casting process ends, here the casting process ends. But these are known as, these terms, heat treatment, cleaning and finishing, additional heat treatment and inspection, these are known as post processing. So in case of sand casting, this is a complete layout of sand casting. This is a complete layout of the process, complete process layout of sand casting. Now this is known as, here it is known as post processing. So post processing. So yeah, we have already discussed about the steps, and now here we can see the process layout of the sand casting. Now in the sand casting, one of the most important, we are going to some detailed discussion so of sand casting. So for that, first we need to know about the sand. So in nature there is two type of sand. First one is silica. The in actually most of the sand casting operation uses silica sand, that means SiO2 as mold material. Now in nature there is two general type of sand, that is naturally bonded sand or bank sand, and another is synthetic sand or lake sand. For better accuracy, for better accuracy means for better dimensional accuracy and low porosity, and good surface finish, synthetic sand is preferred. Sand is preferred. So there are several factors that is important for the selection of the sand for the mold, such as first, sand should have fine round grain and can be packed closely. Thus, it can form a smooth mold, but the that thus it can form a smooth mold. But due to this, if the sand grains are fine, they reduce the permeability of the sand. Permeability means presence of porosity or presence of pores. If this is a mold box, this is a mold box, here the sand particle is there, here the sand particles, say here is the sand particles. Now if the sand particles is very closely packed, if the sand particles is very closely packed, then what happened, then there will be no gap between, the sand particle. That means there will be no gap between the sand particle. That means the sand particle feels like this. And now if in the mold, if in the mold by any reaction some gas is formed, those gas cannot be cannot be moved. Those gas can get interrupted. Those gas can get interrupted in the casting. So due to this, this is a problem. This causes the defect in casting. So that's why what we need to do, we need to create some, we need to take sand which has considerable amount of permeability. That means permeability means the presence of pores. There, that means in the sand good permeability molds should be required. So good permeability molds allow the gas and steam to evolved during the casting process to escape easily. So that means when from the molten metal there is some gas, those gas can escape easily using the permeability, using the good permeability. And another thing should have, for being a molding sand, for the being the mold, that mold should also have good collapsibility. Good collapsibility means it's the ability to strip up, that means there should not be, see, in a mold, if it is the molten metal, due to solidification molten metal will shrink, then and the collapsibility means the the sand wall or the mold cavity wall should remain at its position without breaking up or without chipping up. That means the when the material is shrunken like that, like this, mold cavity wall should be intact, and this can be given by good collapsibility. So collapsibility allow the casting to shrink while the cooling, and thus avoid defects in casting such as hot tearing and cracking. So now we will see, these are all about sand. Now we will see the types of sand mold. Sand molds can be characterized by the type of sand that comprise them, or by them by which the mold is made. The types can be characterized and by the method used to produce the mold. So first is there is three broad types. First is green sand mold, second is cold box mold, and third is no bake mold. One of the most common mold material is green sand mold, which consists of sand, clay, and water. Now, the term green, why it is called green? The term green refers to the fact that sand in the mold, is in moist form. So, the sand in the mold is in the moist form. That means when the molten metal is poured, in the mold cavity, the sand, the molding sand is in the form of, is contain the molding sand should contain some moisture. The molding sand some contain some moisture. So when the molding sand contains moisture, then it is called green sand. So next, it is the least expensive method, and sand is recycled easily for subsequent reuse. So it is the least expensive method. Next is cold box. In cold box process, the various organic and inorganic binders are blended into the sand to bond the grain chemically for greater strength. So there is chemical or organic or inorganic binders are used in the cold box process. These molds are dimensionally more accurate than these molds are dimensionally more accurate than green sand molds, and they are more expensive. In third type of the sand molds are no bake mold. It uh, uses a synthetic liquid resin which is mixed with sand, and the mixture hardens at room temperature. There is no need of baking the material to be hardened. As the bonding of the molten mold is as the bonding of the mold that is in the cold box process, cold box process and no bake mold process takes place without any heat, so they are called cold setting process. So this cold box process and no bake mold process, these two are called cold setting process. Now, so the sand molds can be oven dried or baked. Sand mold can be oven dried or baked prior to the pouring of the molten metal. They are then stronger than the green sand mold and impart better dimensional quality and surface finish to the casting. Because when by heating, by baking, we can remove the moisture present in the green sand mold, so by removing the moisture presence, the porosity will be reduced, and as the porosity is reduced, dimensional accuracy and surface finish of the casting will be increased. Now we will see the some feature of the sand mold. So sand mold in a typical sand mold, the typical sand mold made in a flux. That that whole box is known as flux. The upper part of the flux is known as scope, and the lower part is known as drag. If the flux or if the sand casting is made by more than two part of the molds, then the other parts in between cope and drag are known as checks. Are known as checks. So here is in the getting system, here in the sand molding, we can see that there is a pouring basin or pouring curve through which the molten material is poured through which the molten material is poured. After the pouring basin, there is one tapered like section, that is, in the last lecture we have studied about this is sprue, and at the end of the sprue there is sprue base well. In the case of sprue base well, what is sprue base well? Sprue base well is used to to eliminate the slags. So after the sprue base well, there is runner. Runner connects the sprue to the mold cavity, and the inlet of the mold cavity is known as gate. Inlet of the mold cavity is known as gate. In the mold cavity, there is one thing, that is core. Core is used to make intricate or hollow casting. Core is used to make hollow casting. We will study in detail about core later on. And this is mold cavity, and there is two type of riser. One is open riser, one is blind riser. These risers are feedback mechanism. When due to shrinkage, when the solidification starts due to shrinkage, the mold cavity material in the mold cavity will be less. At that time, from the open riser and blind riser, molten material is supplied to the mold cavity, so that shrinkage does not have any effect upon the shape of the or dimensional accuracy of the casting. So another thing can be added here, that is vent. Vent is added to when the molding material has low permeability. when the molding material has low permeability, at that time vent should be added to to uh, to exhaust the gases that is generated due to interaction between sand and molten metal. So why vent is used? Vent is used for exhaust of gases. So now these are the general feature of sand mold. Here in this slide you can find the detail of the general feature of the sand mold. Those I have discussed just right now. So now I am proceeding to next slide. Here it is only the discussion about what I have told in the last slide. This is mainly for your theory. And now I am coming to the patterns. The patterns are used. What is patterns? Patterns are used to mold the sand mixture into the shape of the casting, and they can be made of wood, plastic or metal. They are usually coated by parting agent. Usually coated by parting agent. So, patterns can be made using 3D printing or rapid prototyping nowadays. Nowadays they are these pattern making can be done very easily, which in turn increases the functionality in casting operation. So patterns can be classified as one piece pattern, where only single or solid or loose piece, also called loose or solid pattern. They are generally used for simpler shape and low quantity production. They are usually made of one piece pattern made of wood, and they are inexpensive. And next there is split pattern. When the patterns are made in two piece, then it is called split pattern. So when they are split pattern, they are made such a way that each part forms a portion of cavity for the casting. In this way, casting with complicated shape. So using split pattern, casting with complicated shape can be produced. And there is another type of pattern which is called match plate pattern. These are the common type of mounted pattern, in which two piece patterns are constructed by securing half of one or more split pattern to the opposite side of a single plate. So what is match plate pattern? That means it is in which the half of one or more split patterns to the opposite side of a single plate can be made. Means in match plate pattern, one or more than one split pattern can be made. So next we will discuss about core. Core is for casting, the internal with the internal for casting with internal cavities. For casting with internal cavities, what we need to do? For casting with internal cavities, or passage, those are found in automotive engine block or valve body. Cores are utilized. How the cores are utilized? Cores are placed in the mold cavity to form interior surface of the casting, and are removed from the finished part during the shakeout or further processing. The core is anchored using the core print. The core is anchored by core print, with the recess added to the pattern to and support the core, and to provide vent for escaping of gases. These are the what function of core print. Now metal support that are due to when the molten metal flow into the mold cavity, due to bouncy force of the molten metal, what can happen? The core can shift. So prevention of this core shift can be made using two metal parts. Those metal parts are known as chaplets. So here in this picture you can see the core prints, core, cavity, parting line, mold, and here you can see chaplets. Here you can see chaplet, core, core print, and cavity. So the example is clear to you, and I guess that till now about the casting process you have getting some ideas. Now in the casting there is some molding machine. So are oldest known molding can be done using hand hammering or tamping or reaming around the pattern. Now this reaming process can be done using molding machine, using different molding machine, the, as a development to the casting process. So some of typical molding machines are vertical fluxing molding, sand slingers, impact molding machine, and vacuum molding machine. These are the type of molding machines. The knowledge of these names is will be enough for now, because in detail study of these molding machines are out of our scope of syllabus. Next, sand casting. How the operation works in sand casting? For sand casting, first we need to design. First we need to mechanically draw the part. So first we need to have a design. According to this design, first cope pattern place is made. Cope means the upper part. So upper part of the molding box, the upper part pattern is made. After that, after that in the drag pattern, there is in the drag patterns. So here the in the cope pattern there is core prints. See very clearly that in case of drag patterns means patterns for the lower body, there is gating system. So as a question one can ask where the gating system is incorporated. The gating system is incorporated in the drag part. Okay, so now core prints, where the core prints is incorporated in both the parts, in cope pattern and in drag pattern. Now by these two pattern, by molding we can make core box now with these two patterns we have to first make the core, because it's a the device has a hollow cavity. So for making a core we need to make a core box first. By from the core box we we make the core hub and put them together. And after the core hub is ready, what we do, we ready the cope for the sand. First we ready the cope for the sand. First we ready the cope for the sand. Now when the cope is ready, we fill the cope with sand. And after reaming, see this is the picture of the cope. After reaming, this is the picture of the cope. After reaming with sand and removing the metal and removing the pattern and removing the pattern sprue and riser. Next, drag is ready for the sand. After the drag is ready, the drag is ready after removing of pattern. Now it is the drag which is ready after removing of the pattern. Now we place the core in the drag. Now we place the core in the drag, and we put the cope above the drag. And when we put the cope above the drag, we close the pin by closing pin. Now we leave it. Now we pour the material from the pouring basin. We pour the material, molten metal, from pouring basin, and we can have the casting. Like we can have the casting as per the design, but along with the gating system and risers and vents, etc. So further processing is needed to remove all this material. Further processing is needed to remove riser, vents and sprue and getting other gating system elements. So that can be done, that is done, and the final product is as per our desired drawing. The final product is as our desired drawing. So this is the final product, this is as our desired drawing. So these are the sand casting operations. These are the sand casting operations. Now now we will discuss about shell molding. Shell molding, this shell molding can produce close dimensional tolerance and good surface finish at low cost. Good surface finish at low cost. And its typical application includes small mechanical part that require small mechanical part that require high precision that require high precision small mechanical part that require high precision, such as gear housing, cylinder head, connecting rod, and other part also is the other process is also sorry. Now the shell molding has application typical application as to make gear housing, cylinder head, connecting rod, and the process is also used widely for producing high precision molding cores. Now the quality of the finished casting can reduce cleaning, machining, and other finishing costs significantly. Complex shapes or intricate shapes can be made using shell molding with less labor, and the process can be automated very easily. The thickness of the shell can be determined accurately by controlling the time that takes that the pattern is in contact with the mold. So now we will see the process. These are the process. This is the process. So roughly from this figure we can say that first this pattern is heated. First this pattern is heated at a temperature of 175 to 370 degrees Celsius. Then it is coated by parting agents such as silicone. So this is the coated by parting agents such as silicone. Then it is placed in a box. Then it is placed in a box. For it is clamped in a box or chamber. Then the box that box contains fine sand mixed with 2.5 to 4% of thermosetting resin binders, and this that coats the sand particle. That means the box contains of coated sand contains coated sand. Then by rotating the box pattern and the drum box by secondly by rotating the box investment is made. See, by rotating the box, the pattern is allowed to, by rotating the box upside down, or the sand mixture is blown over the pattern to allow it to form coating. Then after this is over, then this pattern is placed. This pattern is placed in the oven. The pattern is placed in the oven for a short time of period to complete curing of the for the complete curing of the resins, and then this pattern is these two half of the cells, then the cells pattern and the cells is removed from the drop box, and by adhesive or clamp two halves are joined together like this, and we got our complete mold. Here in the mold, if we pour the material, then we can get the shape of the we can get the desired shape. So this is how cell molding or drop box processing can be done. So now why drop box? Because as the box is being upside down, so the process is named as drop box process. Next is plaster molding. In plaster molding and ceramic molding, these two are the precision casting. That means these two can give close dimensional tolerance and good surface finish. So now, in this process? Mold is made of plaster of Paris. The mold is made of plaster of Paris with the addition of tall silica floor to improve strength and to control the time required for the plaster to set. These components are mixed with water, resulting in a surly to be poured over the pattern. The plaster sets. After the plaster is set, then it is removed. The mold is dried at a temperature range 120 to 260 degrees Celsius. The mold hub are then assembled to form mold cavity and are preheated about 120 degrees Celsius to molten material. Then the molten material is poured into the mold. Patterns for plastic molding generally are made of materials such as aluminum alloy, thermosetting plastic, brass and zinc alloy. Since there is limit to maximum temperature that can be achieved, that can be resisted by plaster of Paris or by plaster mold. The plaster mold can used for casting only of aluminum, magnesium, zinc, and some other copper based alloy. Now ceramic mold casting, it is same as the now ceramic mold casting. It is similar to the plaster mold casting, except it uses refractory mold material. Material suitable for high temperature application, The typical parts that are made using ceramic mold casting are impellers, cutters, machining operation, dies for metalworking, mold making for plastic, and other rubber components. The surly is a mixture here. The surly is a mixture of fine grain zircon, that is ZrSiO4, aluminum oxide and fused silica, which is mixed with other bonding agent and poured over the pattern, which has been placed pattern is placed in the flux. Then the pattern may be made of wood or metal. After setting the mold, the pattern is removed, dried and ignited to burn off the volatile material and bake. The is mold are clamped firmly and used as all ceramic molds. The ceramic fringes are then baked in by fire clay to give strength to the mold. The facing then are assembled to complete the mold ready to be poured. So it is a high temperature resistance. Due to the high temperature resistance of the refractory molding material, the molding material allows this mold to be used for casting ferrous and other high temperature alloys, stainless steel and other tool steel. Although the process is expensive, This process is expensive, but casting have good dimensional accuracy and surface finish over the range of size and intricate shape. So that's why this ceramic mold casting is used. So this is a typical picture of the ceramic mold casting. First, the surly is poured. First, the surly is poured. Then this green sand mold, green surly mold, green mold can be separated, and after the separation, it is burnt off. It burnt off the volatile material. Thank you. This burnt of the volatile material. So thank you. That is it for today. In the next lecture, we will study about the the expandable mold, expandable pattern casting, and permanent mold castings. So for now, this is it. If you have any problem, please feel free to contact with me, and please go through all these lectures to understand more clearly. And another thing, the book I am referring, the book I am saying, there is various book for manufacturing process. You can use P.N. Rao volume 1 and 2. First book suggestion is P.N. Rao volume 1 and 2. This is a good book. P.N. Rao is a good book. P.N. Rao 1 and volume 2. Manufacturing Process by M.P. Groover. It's also a good book. M.P. Groover. And last one is Kalpak Jain. So these are the book I am following for the course, and if you want to follow them, you can follow them. But will suggest to follow P.N. Rao as your textbook, and these two book, M.P. Gruber and Kalpak Jain book, as a reference one. So thank you.